Now let's talk about two-dimensional array. See, already in the previous video we have seen a single dimension array. In programming languages, we can have multi-dimension arrays. So basically we use one dimension or two dimension, or at most we go for three dimension, but languages allow us to declare n dimension arrays. So commonly used one second one is 2D array. This is mostly useful for implementing matrices or for tabular data. Now let us see how to create a two-dimensional array in C and C++. There are three methods of creating a two-dimensional array. So let us look at them. First method is a normal declaration of a two-dimension array along with name of an array, data type of an array, and dimensions. Let us say I want an array of size 3 by 4. So we visualize that an array of 3 by 4 size will be created inside main memory with 3 rows and 4 columns. The indices will be 0, 1, 2 for rows and 0, 1, 2, 3 for columns. We represent a two-dimensional array in rectangular form, that is like a box. But really the memory allocated will be linear. For example, if you want to look at the addresses, let us assume that the first byte's address is 200 and 201. Then this is 2 and 3, 4 and 5, 6 and 7. So this is memory for each integer. As we are assuming that integer take 2 bytes, so 2 bytes for each. This is 206 and 7, and this will be 8 and 9, 10 and 11, 12 and 13. So this means that in real, the memory will be allocated like a single dimension array with 3 into 4, 12 integers. So memory will be allocated like a single dimension array, but the compilers allow us to access that single dimensional array as a 2D array with a row number and column number. So any location if you want to access, then we can say a of, let us suppose here I want to write value 15, then I can say a of 1, 2, this is 1, row number, 2, column number, value 15. So we can access 2D array with the two indices, that is a row number and column number. How compiler will allow us to access as a two dimension, though inside the main memory is single dimension, we will learn it in the coming videos. So if we want to initialize this 2D array, then we can directly mention the list of elements here, like 3 rows and 4 columns. So first row is having 4 elements, 1, 2, 3, 4, and the second row is having elements 2, 4, 6, 8, 4 elements are there, and third row is having the elements 3, 5, 7, 9. So a 2D array will be initialized. So declaration and initialize, this is common in C and C++, the same syntax is used, and the array will be created inside stack because it is just like a variable. There is no new operator used. So once you use new operator, then only the array will be created in heap. So this is the first method of creating an array inside stack. Now let us look at second method, how we can create a two-dimensional array. We can take an array of pointers. So this is a pointer and this is an array of size 3. So suppose I want the same size 3 by 4. So I have taken array of size 3. As this is an array, so normal variable, it will be created inside stack. But this is not an array of integers. This is an array of integer pointers. So I will draw that picture for that one. So this A will be created like this. And these are all pointers. So this is index 0, index 1 and index 2. Now I have just a array of 3 pointers. Now where is two-dimensional array? So I will create two-dimensional array in heap. So what actually I want? I want an array of size 4 so that this pointer is pointing there. Then again an array of size 4. Now again an array of size 4. So I should have 3 arrays of size 4 created in heap. So this is nothing but array of arrays. So there are three arrays and I have this array pointing to those three arrays, and together they form same two-dimensional array. So this is the second method of creating two-dimensional array. Let us see the syntax, how I can create these arrays. So I have an array of size 3. So continuation of this one, I should say a of 0 assign new int of size 4. So an array of size 4 will be created whose address will be stored in a of 0. Similarly, I should do it for a of 1 assign new int of size 4, and I should do it for next location a of 2 assign new int of size 4. So I should create memory in heap for all those three arrays, and this array will be present in the stack, so it will be pointing there. Now, even this structure I can access just like a normal array. Suppose I want to store a value here 15, 1, 2, then I can say that array A, which is the pointer, A of 1 means this one. It's a 2 means this one. I can store value 15. So in the same way I can access it. So these were the two methods. Now I'll show you third method. But now let us look at third method. See, third method, I can take a double pointer. See, one was a two-dimensional array directly inside the stack. Now this is an array of pointers inside the stack, but actual arrays in the heap. Now almost everything in heap now. So for that, I will use double pointer. So declaration of double pointer, integer star star a, asterisk asterisk a. So this a is a pointer, double pointer, and this is like a variable. There is no new operator here, new is not used, so this will be created inside stack. Now I need this array as well as these arrays. So for this first array, I should say a assign new integer of size 3. I am creating this array. So you remember this array was nothing but array of integer pointers. So yes, I should mention star here. So this is an array of pointers of type integer. So an array of pointers of type integer will be created of size 3, and this will be pointing on this one. So if I take the indices, these are 0, 1 and 2. So this itself is created in heap now. Array of pointers is created in heap. Now I will prepare other arrays. So I have to create these three arrays and assign them to these three pointers. So the indices are 0 to 3. Now how to create those three? So same method as I did here, I should say a of 0 assign new int of size 4. Then a of 1, a of 2 assign new. So that's all. The entire structure is in heap now. Only this double pointer is inside stack, because this is new, this is new, this is new. So this is created with new and all three are created with new. Everything is in heap. So that's all. These are three methods. So these are the three methods of creating a two-dimensional array. Completely inside the stack, partial in the stack, partial in heap, everything in heap now. Now one more thing. See, every time I have used new operator. So if you want to know how it is done in C language, then you know very well that malloc function is used for allocating the memory. So wherever we have used new, we have to use malloc function there. Because in C language, malloc means memory in heap. Now last thing, how to access this two-dimensional arrays. These two-dimensional arrays can be accessed using nested to for loops. So for accessing this array or any of these arrays, I can use indices I, let us say starts from 0, I less than 3, because there are 3 rows, and next one more inner for loop, j assigns 0, j is less than 4 because there are 4 columns, j plus plus. So in all my examples, I have taken 3 rows and 4 columns. So 3 rows and 4 columns. So accessing all these elements, so I can say a of I, j, whatever I want to do here. whether I want to print them or modify them or initialize them. Whatever I want to do, I can do it. But this will help me traverse through all the elements in a two-dimensional array, row by row. So it will access like this. First this element, next. Then it will come to next row, all the elements in a row, then next all the elements in a row. Now for accessing all the elements in a row, this is the loop. For different rows, changing the rows, this is the loop. Outer loop is there. So that's all. These are the few basic things that one must know about a two-dimensional array. So I have explained them. Now let us continue with the other topics in an array.